Dear students, today let us discuss about how the electrons have been arranged in various elements. That is nothing but electronic configuration of elements or the atoms. And here, for making this electronic configuration of elements, we should be well versed with Aufbau principle, Pauli Exclusion principle, and Hunds rule of maximum multiplicity. For knowing this, we should know the quantum numbers also. In the last session, we have discussed about quantum numbers in depth. Here also, we'll discuss fairly some components about quantum numbers. I will recall the quantum numbers. The first quantum numbers is nothing but the principal quantum number, which is given by small n, then followed by azimuthal or secondary quantum number. This is given by small l, then followed by magnetic quantum number. It can be either m or m suffix l. Both are right. Some books they follow m, some books they'll follow m suffix l. Then the fourth quantum number is nothing but the spin quantum number. This is S. Okay. So if you want to have uniformity, let us have M alone. So these are the four quantum numbers. As we discussed in the last session, these quantum numbers are used to identify the location of the electrons, how far they are far away from the nucleus, then how about the shape of the electrons, how about their magnetic characteristics, and in which direction they rotate. So all these characteristics about the electrons have been defined by these four quantum numbers. So let us take the example. The nucleus is there. So the neutrons and protons will be within the nucleus. Hence, they are known as nucleons. And the electrons will be in the various orbits. Or we can call them as cells. We can call them as what? Shells, subcells. Then we'll call them as orbitals. Yes, fine. So the cells are nothing but called as the major energy level. Then secondary energy level, these are the orbitals correspond to the magnetic quantum number. Or I can tell the cells are correspond to the principal quantum number, the subcells are correspond to the azimuthal or secondary quantum numbers, and the orbitals are corresponding to the magnetic quantum number. And the orbitals are corresponding to the magnetic quantum number. And hence, this n can take the value as 1, 2, 3, 4, etc. So when n equal to 1, it is called as K shell, and n equal to 2, it is called as L. Similarly, it's M, N, O, if you want, you can increase. And the maximum number of electrons in each shell is given by 2n squared, so it will be 2 into 1 squared, so it will be 2. So the number of electrons in the K shell will be 2. The number of electrons in the L will be 2 into 2 squared, so it will become 8. So L cell will have 8 electrons. And if I am going to have 2 into 3 squared, it will be 18. So the M shell or the M energy level will have 18 electrons, and this N, capital N, will have a number of electrons as 4 squared. So 2 into 16 is 32 electrons. So we can see the maximum number of electrons in the N shell or the N major energy level is 32. Now within this shell only there are subshells. Within the cells only there is called as subshells. So the formula for finding the azimuthal quantum number is given by, if I know n, I can find out what is L. So L is given by 0 to n minus 1. So let us now take the value of n as 1. So let us try to find the value of L. So it is 0 to 1 minus 1. It is 0 to 0, which is nothing but 0. So when n equal to 1, the number of subcells is only 1. The number of subcells is only 1. When L equal to 0, this is called as S subshell. This is based on the shape of the electrons. Here it will be a spherical shape. And when n equal to 2, L will be equal to 0 to 2 minus 1. So it is 0, 1. Which means 0 means it is S subshell, and 1 means it is called as what? P subshell. So we can see when n equal to 2, n equal to 2 means what? It is L energy level. So this L energy level has 2 subshells. One subshell is S and another subshell is what? This is S subshell, it is what? P subshell. Here there is only one subshell, it is only S. Okay, so here this S subshell as well as what? P subshell is there. And when n equal to 3, we can see L will be equal to, if we proceed like this, it will become 0, 1, comma 2. So 0 indicates S, 1 indicates P, and 2 indicates D. So we can see when n equal to 3, it can accommodate 3 subcells. So how can I draw? I can draw like 3. So it is S, it is P, it is D. Okay. So we can see this much of things is there. So what is the max? Similarly, we can go ahead. When I come into the N shell, it will have 4 subcells. It will be SPDF. It will be what? If I proceed like this, it will end up with the SPDF. Now I want to know how many number of electrons or the maximum number of electrons in each and every subshells. In each and every subshells, it's given by the formula 4L plus 2. So it is become 4 into 0 plus 2. You can see the secondary quantum number or asymptotic quantum number starts from 0. So we can see it is 0 plus 2 is 2. So the F subshell can have a maximum number of 2 electrons. Can have a maximum of 2 electrons. If I put L equal to 1, then it will become 4 into 1 plus 2. It will become 4 plus 2, 6. So the P subshell will have 6. Similarly, if I proceed, D cell subshell will have 10 and F subshell will have 14. So we can see that S has 2 electrons, P has 6 electrons, D has 10 electrons, and F has 14 electrons. Here also we can see what are the number of electrons in S? The maximum is 2, P 6. So you add all these 3, 10 plus 16 plus 2, 18. So that will also be in the M major energy level. Similarly, coming to N, the total number is 32. How it is being split? 2, 6, 10. So it will become 10 plus 14, 24. 24 plus 6, 30 plus 2, 32. So we can see that this is how from the major level, within the major energy level, how it has been occupied in the sub-energy level, or that is nothing but your subcells. Okay, so we are very clarified with the principal quantum number and the asymptotic quantum number. The principal quantum number says how far you have been distance from the nucleus. So what is the distance between the orbit or the shells and the nucleus? That is given by the principal quantum number. The asymptotic quantum number defines the shape of the electrons. The magnetic quantum number will define the magnetic property, and the spin quantum number will indicate the direction of the spin, whether it's clockwise or anti-clockwise. So already we have seen this one. Just to recall, we have seen here also. So let us try to move from L to magnetic quantum number. L is nothing but secondary quantum number. From here we will try to move to magnetic quantum number. The formula is minus L. The formula to find M is minus L2 plus L, including 0. So when L equal to 0 means it's called as what? S subcell. Okay, so M will be equal to what? Minus 0 to plus 0, including 0. So it's 0 only. It is what? 0 only. Which means it has one orbital. S subcell has what? One orbital. That's what I told. For principal quantum number, we will call as cells. For asymptotic quantum number, we will call as subcells. For magnetic quantum number, we will call as what? Orbitals. So one orbital. Now the second thing is when L equal to, or I will erase here. When L equal to 1, then M will be equal to minus 1 to plus 1, including 0. So it is minus 1, 0, plus 1. So when L equal to 1 means what? It is P. So we have 3 orbitals. We have 3 orbitals like this. So it is Px, it is Py, Pz. Every orbital can have maximum of 2 electrons. Can have a maximum of what? 2 electrons. So how many electrons can have? It can have 6 electrons. So it can have, first we have to fill it like this. Then we have to fill in the opposite direction. So we'll have 6 electrons like this. When L equal to 2, it is nothing but D. It's nothing but what? D subcell. So M will be equal to what? Minus 2, minus 1, 0, plus 1, plus 2. So we'll have 5 orbitals. So we can have maximum of 10 electrons because each orbitals can have 2 electrons. So we can have 10 electrons. The spin quantum number defines the direction of the spin. Okay, if I have only 1 electron, it will be here. If I have the second electron, it has to go to here only. It should not come here. It should go to the next orbital only. There's a third electron, then here. Fourth here, fifth here. Sixth electron only should occupy the first one. Then only it should be rotating in the opposite direction. There is nothing but spin quantum number will always have only 2 values. One is plus half. If it's going to be anti-clockwise. When the arrow is like this, it is anti-clockwise. I should draw like this. Okay, so it is going to rotate anti-clockwise. Then S is equal to plus half. If it's going to rotate like this, it is clockwise. So it will be or downward action. I can't tell clockwise or anti-clockwise. I can tell this downward action, this upward action. Upward action is plus of, downward action is what? Minus of. So we can see there are two quantum numbers, spin quantum numbers for these things. So we have discussed more about the quantum numbers. Now what this Pauli exclusion principle says is that no two electron can have the all the set of four quantum numbers the same. Okay. Now let us take an electron in 2s. Let us say it is 2s1. The other electron is what? 2s2. What here the 2 indicates? The principal quantum number. What the principal quantum number here indicates? It's the second level. So it is what? L. We know it is K, L, M, N. So it is nothing but what? My principal quantum number is 1, 2, 3, 4. N equal to. So here n equal to what? 1, 2, 3, 4. Now we have 2. This indicates the principal quantum number. So it is L cell. It is called as L cell. What the small s indicates? Subshell. Which subshell? S subshell. And is going to have the first electron. Okay, so I can draw like this. Only one electron. Now let us draw 2s2. This is what? 2s1. Otherwise, I can make it still more clearer. I will write for lithium and or I will write for beryllium. Beryllium, its atomic number is what? 4. So what is the electron configuration? It will be 1s2, 2s2. 1s2 what? 2s2. So 1s2 means how I can write? I can write like this. 2s2 means what? I can write like this. Now let us take this last electron. Or let us compare these two electrons. 2s1 and 2s2. Let us compare between what? 2s1 and 2s2. For this one, what is n? N is 2. For this electron also, what is n? N is also 2. What is the azimuthal quantum number? The azimuthal quantum number L equal to what? 0. Why 0? Because here also S, here also S. So here also L equal to what? 0. 0 means what? S subshell. What is the magnetic quantum number? When L equal to 0, what about M? M will be equal to minus L2 plus L, including 0. But here already 0 only. So minus 0 to plus 0. So 0 only. So here also what? Magnetic quantum number is 0. Here also the magnetic quantum number is what? 0. But let us come to the spin quantum number. One it is in the positive, one is in the upward action, one is in the downward action. Whenever it is upward action is plus half. When it is downward action is what? Negative half. So we can see, even though the first three quantum numbers are same for both this electron, even though the first three quantum numbers are same for both this electron, but the fourth quantum number, spin quantum number, is different for this one and this one. This what the Pauli exclusion principle says. The Pauli exclusion principle says that no two electrons in the same energy level or in the same subshell can have all the set of the four quantum numbers the same. At least it should differ in at least one quantum number. That is the one of the example here we have seen here. Okay. Let us now try to take an example with 2s1 and 3s1. Let us now continue with the 2s1 and 3s1. Here 2s1 means what is n? N is nothing but 2. Here what is n? The principal number is 3. What about L? L equal to 0. Here what about L? L is also equal to 0 because here is also S only. What about the magnetic number? That will also be 0 only. Here also what? 0 only. What about the spin? Both are having only one electron. It is in the 2s. It is in the 3s. Sorry, it is both in the upward action. So S will be what? Plus of. Here S is also what? Plus of. Here you can see, even though these three quantum numbers are same, L equal to 0, here also L equal to 0. Here M equal to 0, M equal to 0. S equal to plus of, S equal to what? Plus of. But what about the principal quantum number? It is varying. So we can see that no two electrons can have all the set of four quantum numbers the same. That is nothing but called as your Pauli exclusion principle. Why we should know this one? Why we should know Pauli exclusion principle? That is for how we can arrange the electronic configuration of various elements. Starting from the first element hydrogen to up to now 118 elements are there. So up to that we have to write all these elements, their electronic configuration. So this will be useful. So this is nothing but your Pauli exclusion principle. Now let us come to Aufbau principle. Aufbau is not the name of a scientist, whereas Pauli is the name of a scientist, whereas Aufbau is not the name of a scientist. In German term, is called as building up of or build up of. Okay, so it's called as building up of electrons. How will I construct a house? First, I will construct the house with the first layer of bricks. Then over that, I will put the second layer, then third layer, then fourth layer. So first, the lower layer energy level should have to fill. Then only I can go to the first level. For even if I am going to fill the container with some water, where the water will first get stored, it will be stored at the bottom level. Then it will come for this level. Then it will occupy this level. So we can see the first it will occupy the lowest energy level. Then it will come the higher energy levels and it get filled up. Now my question to all of you: after filling it up, which will have more energy? When you are filling it up, the first energy will have the lowest energy. I agree. So it is first I am building the first level. Then I am going to keep the brick over here. Then the third layer of brick is here. So I am going to come from the bottommost or the lowest energy to the highest energy level. That's fine. After filling it up, which will have the major energy level? Bottom one. Okay, if for example, if I am going to fill the water also, after filling, where the pressure will be high, the pressure will be high here only. The pressure will be low here compared to here. Okay, similarly, once I filled the electrons, first the 1s energy level will have lower energy, 2s energy level will have higher energy compared to 1s. Then will come 2p. Then will come what? 2p. Then will come what? 3s, 3p. So we can see that 1s has lower energy compared to 2s, compared to 2p, compared to 3s. Okay, once I filled up to 3p, let us assume that I filled the electrons up to what? 3p. Now if I am going to remove the electron, whether I can remove the electron easily from 1s or 3p? 3p. So that the trend will become reversed. The trend will become what? Reverse. Similar to the water which is stored in a container. The pressure at the bottom will be higher compared to the pressure at the top. Okay, I hope you got the logic. Okay, when filling up only, the energy will be lower. After filling it up, it's very difficult to remove an electron from the 1s orbital compared to the 3p orbital. Okay, fine. So this point you have to take in mind, because whenever they are generally discussing about Aufbau principle, they will tell you only in one direction. One direction means they will tell the lowest energy level will get filled first, then followed with the highest energy level. But after filling, the reverse will take place. That concept I want to stress over here. Okay, fine. So let us now consider when n equal to 1, L will be equal to 0. How we got this one? Because the formula for L is 0 to n minus 1. When n equal to 1 means 0 to 1 minus 1, 0 to 0, L equal to 0. When n equal to 2 means L will be equal to what? 0 to 2 minus 1. So 0 to 1. So it's 0 comma 1. When n equal to 3 means L will be equal to what? 0 comma 1 comma 2. Because you put the value of n is 2 here. So 0 to 2 minus 1. So it will become 0 to, I have to put n equal to 3. So it is 0 to 2. So nothing but 0 comma 1 comma 2. Okay. So like this. When n equal to 4, L will be equal to 0 comma 1 comma 2 comma 3. When n equal to 5, L will be equal to what? 0 comma 1 comma 2 comma 3 comma 4. Now what is n equal to 1? What is the name? K, capital K. What is L equal to 0? Small s. We have to call as small s. Here it is called as what? Capital L. Here L equal to 0 means small s. 1 P. So it is what? SPD. It is 3, capital M. Okay, so it is this one. Okay, now we can see, so for 1, I will write as 1s only. 1. Why I am writing 1s only? 1 is nothing but my principal quantum number. S is nothing but what? My azimuthal quantum number. I am coming to second one. Second one I have 2, but both S and P. But both what? S and P. So it is 2S, 2P. Got it? Why I written here? 2S as well as 2P. When I am coming to 3, it is 3S, 3P, 3D. So it is 3S, 3P, 3D. When I am coming to 4, it is 4S, 4P, 4D, 4F. Okay, so it is 4S, 4P, 4D, 4F. Coming to 5, it will become 5S, 5P, 5D, 5F, and if you want, you can add 5E also. If you want, you can add 5E also. Now, I am going to, now which is having the lowest energy? 1 is having the lowest energy. Then 2 is having the lowest energy. So, I will draw a diagram. Okay, so you can see 1S, 2S, then actually you have to follow like this. Got it? So then we'll go like this, then like this, then here it will be 6S. It will be what? 6S. Okay. Now we can see how is taking the transformation. Always please indicate the direction. Direction is very important. Otherwise you may make a mistake. Okay. Now we will write it. Now we can write. How to write? 1S, 2. Why? Because we know S will have maximum 2, P will have a maximum of 6 electron, D will have a maximum of 10 electron, F will have a maximum of 14 electrons. So 1S2. Then after 1S2, we have to come like this. 2S2. Then 2P, 6. Because P can have 6. Then 3S2. Then 3P6. Then 4S2. Then it is 3D10. After 4S, you can see here, it will be 3D10. After 3D10, it is 4P6. It is 5S2. So here, this is another problem. After 1S only 2S only coming. After 2S only 2P is coming. After 3S only 3P is coming. After 3P, 4S is coming. That's also fine. But after 4S, once again we are going back, 3D. So we are unable to tell whether 4S is having lesser energy compared to 3D. Here the competition is, or the question comes like this. Whether 4S has lower energy compared to 3D, yes. So the only 4S is getting filled first before what? 3D. So this principle is nothing but called as what? Aufbau principle or building up of principle. This one we have to devise and it will be useful. For example, now let us take me an example of say calcium. Its atomic number is 20. Its atomic number is what? 20. So how we can write 1s2? So out of 20, 2 electrons are over. Remaining is 18. So 2s2, 2p6. So far how many electrons are over? 10 electrons are over. Then 3s2, 12 is over. 3p6, 8 is over. 4s2. So how much is over now? 20 is over. So like this, the electrons have been arranged in calcium. So you should not write first 3D. You should not write 3D 2. You have to write only 4s2. So you can see 2, 4, 10, 12, 18, 20. So how to write? If you want to write, I can write now. So 1s2, 2s2, 2p6. Then 3s2, then 3p6, then 4s2. So this one, this. I hope you got it. So this is how the electrons have been arranged in calcium. The electrons have been arranged in calcium. Similarly, you can try to extend even up to the last element. You can write for carbon. What is carbon? Carbon is very important because organic chemistry is depending on carbon. So it's atomic number 6. So how to write? 1s2, 2s2. Then how I have to write? 2p6. No, don't write 2p6. Because total number of electrons is 6. So 2 is over, 4 is over now. So remaining is what? 2. So we have to write 2p2. We have to write what? 2p2. So what is the electron configuration now? It is 1s2, 2s2. Then coming to 2p6, it is 3 orbitals are there. px, py, pz. So now there's a doubt for you. So whether I have to write the 2 electrons like this. If I'm writing like this, it is wrong. If you're writing like this, it is there are 2 electrons. I should not write both electrons in the same orbital. I have to write the second electron in the second orbital. I have to write the second electron in the second orbital like this only. Then only it is right. Why? This is given by Hunds rule of maximum multiplicity. This is given by what? Hunds rule of maximum multiplicity. When I studied chemistry under my professor, at the time, during 92, 93, so he used to explain like this. What is this one? What is this one? You assume this is a bus. This is a bus where you are going to travel from one location to another location. You are trying to get into the bus. Now, one person is already seated here. One person is already seated here. One person is already seated here. Now these two are vacant. Now these two seats are vacant. But every seat has a capacity of holding two members. Every seat is having a capacity of holding what? Two seats are available. So let us tell it is okay. It is L3, L4. It is L1, L2. Now you are entering into the bus. Where you will sit? Whether you sit in L1, L2, L3, L4. Here it is L5, L6. Other side is L7, L8. Okay, L9, L10. Where will get seated? Yeah, we will be interested to sit either in L9, L10 or L6, L5. Why? Because we are new to the bus, we want to preserve our individuality, so we don't want to combine with others. We'll go and happily sit in the window side, and I used to prefer either L5 or L9. And I used to prefer what? L5, L9. Then when you'll get paired up, now let us consider, I am going to, already this seat is also filled up. This seat is also filled up. Now where will sit? Now you see, every seat has one person already occupied. Now where you sit? Now anywhere you can go and sit because there's no way. Now only pairing will take place. Now only pairing will take place. So now if I enter into the bus, I will see any seat is there free. No, your seat has been filled with one member. So I will either go to this one or this one somewhere. There's no other choice, I have to pair it. Similarly, even though there are three orbitals in the P subshell, I will not go and pair immediately here. I will choose my individual seat. If there is one more electron, if it's 2p3 means I will go and choose here. If it's only 2p4, there's no other way, I had to go and occupy here. This example was told to me by my professor Dr. Lakshman some 20 years back. But still, we are able to recall and we are able to understand the concepts. So this is nothing but called as your Hund's rule of maximum multiplicity. This rule says that pairing of electrons will take place only when all the available orbitals have one electron each. So pairing will take place only all the orbitals have at least one electron. If it's already having one electron each, then there's no other way, then I have to go and pair it. So this theorem should also be there. So now let us recall about all the principles. The Aufbau principle says that you have to first fill the lowest energy level, then you have to go to the next higher energy level. In that way, you have to build up the electrons. That is the first principle, very simple principle. Okay. Then let us come to the Pauli Exclusion principle. It says that no two electrons can have all the set of four quantum numbers the same. Definitely they will vary in one quantum number at least. So that is nothing but what? Pauli Exclusion principle. Then coming to Hund's rule. The Hund's rule or the Hunds rule says that pairing of electrons will take place only when all the available orbitals have at least one electron each. If you are well known about all these three principles, then building up of the electrons or the electron configuration of any element is not difficult. It's not a difficult task. Okay. Just. Now let us take carbon. Its atomic number is 6. Its atomic number 6 is 1s2, 2s2, 2p2. There is no doubt in that. Okay. Now I am telling 1s2, 2s2, 2p2. It is violating which rule now? Whether it's right or wrong, first of all? It's wrong. Why? This electron should be moved to the next one because pairing should not take place when all the available orbitals should have at least one electron each. So which is violating now? It's violating the Hunds rule because this electron should not be here. This electron should be here. Instead of this electron here, it should be here. So it's violating the Hunds rule. Now let us leave it. It is also violating which rule? Pauli Exclusion principle. Why? Both the electrons have the same spin. So that is also not possible. So this also wrong. Even if it's at least like this, we can say it is obeying the Pauli Exclusion principle but not obeying the Hunds rule. But if I am going to draw like this, it is not at all, not only disobeying the Hunds rule but also disobeying the Pauli Exclusion principle. So the right order is that this is the right one. This is the right one. Got the logic? Similarly, you have to fill up the 4s before what? 3D. There is another way to check the Aufbau principle. There is another way to check the Aufbau principle. If you are not able to draw like this, if you are not drawn like this, then how you might fill the electrons? If you are not written like this, then how you might fill the electrons? Yeah, like that you may. Very good. After 3p, you might fill the 3D. Okay. So I'll do like this. So it is 1s, 2s, 2p, 3s, 3p, 3d, 4s. I'm writing normally. I do not know whether it's right or wrong. Okay, then 4p, 4d, 4f. So it goes on like this. Then 5s, 5p, 5d, 5f, 5e, etc. Okay, so we are writing like this in the order. Now let us try to find what is n, what is L. What is n? Principal quantum number. Yeah, it is 1. Very good. What is L? 0. S means 0. What is n equal? What is 2? N equal to 2. What is L? 0 only because S is 0. Very good. So here once again 2. What is P? 1. Okay, because L equal to 0, 1, 2, 3. It is what? SPDF. Got it logic? So 1 means P. Now you tell it is 3. It is what? 0. It is 3. It is what? 1. It is 3. It is what? 2. D is what? 2. Then 4, 0. Then 4, 1. 4, 2. 4, F means 3. So what I done? I am not trying to draw a structure like this, but I simply written the normal way. What is normal way? 1s. 1 means only one letter. 2 means 2 variables, 2s, 2p. 3 means 3 variables. 4 means 4. 5 means 5, like that. Okay. Then what I am going to do means I have written the n values and l values. Then I am going to summarize them. N plus l. I am going to add them. When I am going to add them, it becomes 1, 2, 3, 3, 4, 5, 4, 5, 6, 7. Isn't it? Just I am adding the n and l. What is this 1? 1 is right. 1 is 2. Because 1 is less than 2. 1 is less than 2. So it is 2 means what? This is also right. First I can write right. This is also right. 3. 3 means this is also right. What is 3 correspond to? 2p. So 2p6 is also right. What is 3? 3s2 is also right. 3 is 2 also right. Okay. Now coming to 4. Both are 4. Both are what? This also 4. This also 4. 3p. Yeah. So which one you had to write first? We had to write this one. It is having the lower principal number. So it is 3p6. Then which 4 is coming? After this one, we had to write this one. Because this is also 4. There are 2 4s. 4s2. But among these two, which one I had to give preference? I had to give preference to 3p. Because 3 is having lesser number compared to 4. Got it? What I am telling? So 3p6, 4s2. Then which one have to come? There are 2 5s. There are 2 5s. So which 5 I have to give importance? There are 2 5s. Which 5? 3D. Because 3 is lesser number compared to 4p. So it is nothing but what? 3D, 10. Then 4p, 6. Now you see, once again, 4s is coming before 3D. Whether you have to draw a diagram like this and we have to write this order. Otherwise, if you don't want to write like that, then we have to make a statement like this. Then you have to find N and L. Then you have to summarize. Then you have to see and you have to write like this. Here also we can find that 4s has lower energy than 3D. So 4s2 will get filled up earlier compared to what? 3D10. So this is also the another way of approaching the Aufbau principle. Another way of approaching the Aufbau principle.